Are we live?
Yes, sir, we
Yes.
are live.
Okay. So, Patrick, where were we? What we were doing? We were doing the yesterday about the
Hydrogen
Lamber
spectrum.
and Palmer and yes,
Lyman,
Judith
Barber,
Lamber.
Paston, Brackett, Fund, and Humphrey. These six.
Yes. Okay. Now today we will the let me check what is in your book. We go according to your book. Okay. Let me find. Check. So atomic structure, we did that energy level diagram of hydrogen atom. Now we learn about the Lyman series, Lama series. In your book, why there is no force,
Huh? What, sir?
force, force is there. No, I guess now the force is there. Okay, now write about force model. Put a heading. Force model. Force. Put a heading. Force model. Force model. Now, what is Bohr's model? So we learned that Rutherford was unable to do one thing. Okay, Rutherford was unable to explain the electronic configuration of an atom. He says that electrons revolve around the nucleus, but because of that de Broglie statement, that particle release means a charged particle when it is having acceleration, it will have two waves and it will lose energy. Okay, and if it will lose energy, then it will make a spiral around the nucleus, and if it will make spiral around the nucleus, then obviously it will die. I mean, it will go into the this thing nucleus. Yes or no?
And it
Okay,
goes dishum dishum.
dishum dishum. Yeah, I mean, like the table is in front of you. After some time, boom, it will become like this.
Yes, sir.
But Niels Bohr, okay, he came with the idea and he resolved everything. Okay, so
Yes.
put a heading, Bohr's model. Put a heading, Bohr's model. Write it down. In
Yes.
order to come, there today little bit theoretical part is there. I am giving you notes so that it will be easy for you to understand. Okay,
Yes.
write it down. In order to overcome the drawbacks of Rutherford, in order to overcome the drawbacks of Rutherford's model, and to explain and to explain line spectrum of hydrogen, to explain line spectrum of hydrogen, Niels proposed Bohr's atomic model. Bohr's atomic model. So there are some postulates that you need to learn because they can ask you in short question answers or long question answers. The first postulate is the electron move in a definite electronic circular. The electron moves in a definite circular path around the nucleus. He called the circular path as an orbit. So you have to learn this postulate which is in your book. So we will not write in your copy, but we will understand each one by one. So you have to learn this. Okay, so put a star mark. If the book is open, then put a star mark on these 3 points that you have to learn. Okay, the first is because we learn in the 10th class also, that is why I'm not focusing on writing these things in the notebook again. Did you understand, beta?
Yes, sir.
Okay, so the first is the electrons move in a definite circular path around the nucleus, and he called these circular path as orbits. Okay, postulate as long as electron is in given orbit, its energy does not change. Okay, so the electron basically, as long as the electron in the orbit, if the electron is revolving around the K series or L or M like this, then the energy will not change. It will not radiate energy. Okay, so that is why they are called as stationary orbits. So now they can ask you this question. You can make an underline this, or you can write this question also. Why the orbits are called as the stationary orbits? Because they have a fixed energy. Okay, if the electron is revolving around it, it won't change the energy. This is the first postulate that he gave. Did you understand?
Yes, sir.
Okay, the second one is the electron can change its orbit by absorbing and releasing the energy. So this postulate explains the line spectrum of hydrogen also. In hydrogen, when it get excited, why it get excited? Because it absorbs that energy. The electron absorbs the energy. It go to the Paschen or P fund or Humphrey, and then when it releases the energy, it will come back to the Lyman, like in step by step. So this is the second postulate which Niels Bohr says, and it explains the line spectrum of hydrogen also. Did you understand?
Yes, sir.
No.
Yes, sir.
Okay.
So
So
this
we know.
also, so this also
Yes.
we learned in the 10th class, sir. Yeah, this also like the formula E is equal to H into V.
H into mu, which is mu is frequency.
Yes.
Okay. So second postulate, which says that it can be absorb and release. Absorb and then release. So E is equals to H mu. Okay. So there is one more formula like delta E. What is delta E means? Change in energy. Change in energy, which is equals to H mu, and change in energy is also equals to what? Is also equals to EF, means final energy minus initial energy.
Yes, sir.
Okay, final energy means going to the final state, and what is the initial state? What is the house of the electron? Okay, I'm saying house of the electron. Why? Because the electron was there in that place. Okay,
Yes,
now
sir.
listen, guys. A electron which can go from lower orbital level to higher orbital level, is it possible a electron in the higher orbital level will go into the lower orbital level? Is it possible?
So, I mean,
For
in the
example, a electron in M shell, can it go to the L shell?
it needs to get de-excited, then only it can go.
So de-excitement, is it possible for that?
De-excitation.
See, the thing is, I think it's like I'm giving the answer. You also search for that. Okay. I think it is not possible. Why? Because if the electron is revolving in the M shell, so it means that L and K shells are fully filled according to the Hund's rule or Paul's laws or Aufbau principle. Did you understand what I'm trying to say?
Yes, sir.
So K and L shell is totally filled. Okay, and even if you want to remove the electron from K or L shell, it is not possible because what Pauli's principle we are going to learn says that the electron can remove from the outermost shell only, not from the middle. So you can't remove the electron in the middle also. This is what I think. What is
So,
your idea?
so like to
Yes.
like basically like to remove the electron from the middle, you need like a huge amount of energy, which is not possible.
Yeah, which is not possible. So, electrons, I believe, can like the house state is M. It cannot go to the K shell. Either the K shell are totally filled, which is two is already there, Are you getting my point? No.
Yes, sir. So in the case
Hmm?
where already two are there, so an electron can't come from M to the K because K already has two electrons.
Yeah. So you also search. Okay, I'm not saying my answer is final answer. I will also search after this because the thing is, when I'm doing this chemistry, na, okay, I am also getting this question, and I want you also to get these types of question because chemistry is all about research. Okay. So you also research and you also think, and then tomorrow we'll come up with this idea. I mean, it's on Thursday. Got it? My point? No.
Mm-hmm.
Okay. Now, second one. Similarly, when electron changes its orbit from higher state to the lower state, the single photon energy Hi is removed. Okay, so if an electron moves from like it got excited and it coming from the this thing from lower energy to the higher energy level, then it will release a energy which is H mu. Okay, got it? So if it will absorb the energy, then it will go excited. If it will release the energy, then it will come back to the lower energy level. Got it? My point?
Yes, sir.
Okay. Now there is angular momentum. Angular momentum, I guess you have learned in the physics also. Angular momentum. What is angular momentum? Can you tell me?
Yeah, angular momentum formed as MVR.
No. What is the meaning of angular momentum?
Like the momentum,
Moment.
I mean,
Hmm.
I have not learned angular momentum like right now, but like not even in the physics because like we just started it. We just started
Okay.
like the portions of physics and physics in Allen's also. Yeah. In,
Okay. So for example, this is a we say that this is you. Okay, and you have one thread and you are revolving that bob around like this. Okay, you are doing like this, like a cowboy. Okay, so that stone which you are revolving around it, now it is not going in a straight line, it is going around the angle. Like every time it is going like this around the angle. Got it, my point?
yes, sir.
So in that case, we have to calculate the angular momentum. Now, angular momentum formula is m into mass of electron, which is me, into velocity into the radius. Which radius? Like this is the radius, no? So mvr. Okay, and it is equals to the angular momentum of an electron is equals to nh upon 2 pi. Now what is n? Like I will write everything. Okay, m e stands for mass of electron. Okay, v is stands for velocity, r stands for radius of a orbital, and n stands for principal quantum number. Am I correct?
Yes, sir. N is principal coordinate number, sir.
Yes. That just give me a second, bro. N stands for principal quantum number, and and one more.
H.
H we saw H is Planck's constant. What is the value of that?
Uh, 6.6
6.626 into 10 to the power minus 27.
minus 34
So 31 erg and 34
joule.
joule.
Yeah, 34 joule.
34 joule per
No,
second.
joule into second. Joule into second. Joule second.
Joule second, no?
JS. JS.
Joules, joule second.
Sir, basically it's not 6.26, it's 6.626.
626. 6.626. Correct. Okay. Now, we learn the second law also. Is there any problem? No.
No
Now,
problemo.
no problem. Now we will understand. So write it down. This thing, write it down. Angular momentum part.
I don't know the momentum.
Because the red energy has less energy, red light has less energy as compared to violet color. So if a orbit, if a electrons, wait, just give me a second. The squirrel is roaming around and it's coming in the bag. Sorry for that. What I'm trying to say that if a electron comes from three orbital to the second orbital, means from Paston to the Balmer, then what happened? It has the difference. The energy difference is less. Less energy difference means less energy color light will be visible. So which color will come? Red color will come. Got my point? No.
Yes, sir. Got it. Got it. Got it. So red
Okay.
has more wave. So red has more wavelength, and that means red has less frequency, which means red has less energy.
That's less energy. So if the light is coming from three to two, means three principal quantum number shell to the second principal quantum number shell, then in that case, what will happen? That the less energy difference is there. And if less energy difference is there, less energy wave will be there and red color will be there. Did you understand my point? No.
Yes, sir.
Okay.
Mm.
Done with
Yes,
the
sir.
writing. Now write one thing. So frequency, how much frequency or how much energy is absorbed or released is depend upon the change in the energy level. Like if a orbital is going from first to the second and second to the third and third to the second, in that case we have to calculate the initial energy minus final energy and then we have to subtract it. Then we will get the delta E which represent that this much energy change is there between the electron means this much energy electron gains to go to the another higher level. Are you getting my point? No.
Yes, sir.
You don't understand, no?
I think this much energy the electron needs to go to a higher energy level.
For example, if electron goes from second to fourth. So
Yes.
fourth energy level minus second energy level, if you will subtract it, so this electron, which is my nose, this took that much energy to reach to the fourth energy level.
Yes, sir.
Got it?
Yes, sir.
So if the question will come that how much energy is absorbed by a electron when it was initial state as 2 and the final state was 4. So in that case we have to calculate the second orbital energy, fourth orbital energy, subtract it, we'll get that this much energy electron will absorb. Are you getting my point?
Yes, sir.
Okay. Okay. Now, first, before that, we'll write it down. One thing significant. Write the heading. This is not in your from your book. That is why we have to write everything. Significant significance of Bohr's model. Significance of Bohr's model. Significance of Bohr's model. First point. First point is stability of an atom. Okay. First point is stability of an atom. So obviously, if the electron revolving around the nucleus, okay, if it does not radiate the energy, if it is not radiating energy, it will have a fixed path and the electron will not become unstable. It will be always stable. Got my point?
Yes, sir.
So you write this line in your own word, which I am saying. I will say in a one way, one breath, and then you have to write it down. So electrons revolving around the nucleus, they do not radiate energy because they have stationary orbits. Hence, it is not possible for an electron to radiate or to lose the energy or become unstable. You got my point? No.
Yes, sir.
Okay. So please write it down in your own words. Edric, you are getting the chemistry from Meena.
Yes, sir. Yes, sir.
Pak, Pakka na?
Ah,
If you have any doubts, please ask me. Okay.
yes. Yes, sir.
Done writing?
Almost. Done, sir.
Okay. Now, write the second point. Calculation, calculation, calculation of Bohr's model. Calculation of Bohr's model.
Yes, sir.
Calculation of Bohr's
Model.
model radius. Model atomic radius. Bohr's model atomic radius. Second point.
Yes.
Now, if you want to find the atomic radii,
Yes.
like I told you, na, in the angular momentum we need atomic radii.
Yes.
Just
Like
give me a second.
mvr is equal to n by 2 pi. We need that r value.
Ha. If you need that R value, then what will you do?
We have to calculate the radius.
Yeah. So for radius, there is a formula. I will give you the easiest formula, which is A naught is equals A naught into N square by V. This is the formula for the atomic radius. Rn is equals to A naught into N square by Z. So now what is that? N is the principal quantum number, like which first, second, third, fourth, like that. So it will be principal quantum number. Principal quantum number. A naught stands for 52.9 picometer. Means this is the value that you have to learn. 52.9
9 pico.
picometer. And Z stands for atomic number. Okay, so if you will calculate the first atomic radii, like the K shell atomic radii of hydrogen, how much it will be?
So the K shell of the hydrogen atom will be A naught into n in 1 into 1 divided by 1. So it will come A naught, which will come 53 picometer, 52.9 picometer.
52. You got my point?
Yes, sir.
No.
Easy, sir. Easy.
A0. Oh. So it's picometer. Remember this. It's not nanometer. They will tell you to nanometer, and you can change it.
So
Okay?
they give a nanometer to convert it into picometer, right?
Yeah.
Yes, sir. I will do it.
Okay. So here Z is called as the nuclear charge. Z is not atomic. Z is nuclear charge. Nuclear.
Yes, sir. Done, sir.
Oh, means that correct. Okay, so now we got one relation with this. Can you see that? That if the value of Z will increases, then radius of the like first, if I will say first K shell, if I will talk about, then if G increases, like helium of first shell and hydrogen of first shell. Are you with me?
Yes,
Getting my
sir.
point? So what is the difference between them? That the helium of first shell will be less than the hydrogen of first shell. Means helium of radius first shell, sorry, helium of helium of radius of first shell, okay, is smaller than hydrogen of radius of first shell. If I will take helium first shell, hydrogen first shell, we got relation that as the value of atomic number increases, like 4, 5, 7, then radius will decrease. The same first shell if you are talking about. Second shell, if I'll compare, are you getting my point? No.
Yes, sir. Yes, sir. I am getting a point. So, like, the atomic numbers. uh, increases, the radius will decrease. But if the shell number cast square increases, the radius will increase.
Is correct because if radius will not increase, then if it will decrease, then that is no point. But what I am trying to say, if I will take first shell of hydrogen and first shell of sodium, okay, which will have more radius?
First shell of hydrogen.
Yes, that is the point. Okay, got my point?
Yes, sir. Got it.
Okay. Um, okay, write it down. One question I'm giving you.
Sir,
Which? Yes,
sir. When is the test for chapter one?
tomorrow, na?
Yes, sir. Tomorrow, right? Yeah, tomorrow.
Yesterday.
I will remind you by 12 o'clock or something.
Oh, got it.
Because tomorrow I don't have Ellen,
Okay, sure. I will send it to you.
and 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 you saying that Saturday will correct it and Sunday you will send me. Okay.
Yeah. Saturday I will correct it. Saturday only. No problem. Okay. Now write it down. One question. Which state of triple? Write it down this question. Which state?
Wait. Okay. Hmm.
Which state of triple ionized beryllium, which is Be plus has the same object radius as as the ground state of hydrogen atom. Means, mean, this means that which state of triple ionized beryllium atom? Okay, triple ionized beryllium atom means that three ions are removed. Okay, triple ionized beryllium atom will have the same state like that. So we have one relation. What is the relation? That hydrogen, like what is the formula of hydrogen?
So I become A naught into one square by one. Are you going to
So hydrogen radius will be
A naught?
first will be in. Okay, got my point?
Yes, sir.
And now we have to check what is the value of beryllium, hydrogen, helium, beryllium. Beryllium is 3. Okay,
So the N will be uh, okay. So
that
N
will be what?
you have to find the value of N, and the value of Z will be 4 because the beryllium's atomic number is 4.
Beryllium atomic number is 4. Then, so it is like this. This is for hydrogen.
Yeah. Now for beryllium become R2 is equal to A naught into N square by Z is 4.
Yeah, A naught is equals to
A naught
N square, which is A naught, which is 2 square upon 4, which is Z. So R2 is equals to, yes, Edric, you're saying something better?
wait, A naught into N square divided by 4. N
N square, no, so N square I put as 2, no, because I am getting the answer as 2.
square. And yes, sir.
You got my point? No, you didn't get it.
Got it, sir. Got it, sir.
So if I will put N, then this will become what?
N
N.
square.
Okay, I'll put that. Okay, then
and saying that R1 is equals to Rn, so you can substitute A naught in this equation. That means A naught is equal to A naught into n square divided by 4. A naught into
So can I write it like this? 4
A naught.
R N, okay, upon A naught is equals to, no, sorry, upon N square, N square is equals to A naught. You got my point? No. Agree. You got
Yes,
my
sir.
point, Peter?
Yes, sir.
Now, can I write 4 R N upon N square is equals to R1? I will do one thing now. You don't need to do this. We'll do one. See, we know that we need the answer as A naught, no? Edric,
Yes, sir.
can you see this? What we need answer A naught. So what will I put the value of n to get the answer as A naught? 2 only, no?
Yes, sir.
If I will take R2 of beryllium atom, beryllium plus 3 atom, then it will become what? A naught 2 square by 4. So R2 is equals to A naught 4 by 4. This and this will cut. So this is also equals to second A naught. So
Yes.
this is hydrogen first shell and beryllium second shell.
So
They
n is
both
equals
have
to,
same radius.
yes. So n is equals
If
to 2, right? Yes, sir.
yeah, n is equals to. Cut. You got my point?
Yes, sir. Got it.
So we'll end this class then Edric. Tomorrow today I want to give some homework. You do one thing. In-text question 2.4, question number 1 and question number 2. Yes.
Index 2.4, question number 1 and 2, right?
1 and 2. Okay.
Yes, sir.
So I hope you have enjoyed the class. And bye. Have a nice day. We'll meet tomorrow.
Thursday.
Thursday. Bye. Okay. Bye, Edric.
Bye, sir. See you Thursday. And
Bye.
and the test is tomorrow for me, right?
Yes.
Okay, sir.
Nice to meet you.